So when I mean repeated multiplication, what I mean is if I have x times x, how do I write that as an exponent? Go ahead, Adam. Yeah, x to the power of 2. And so when you're seeing those exponents, it's important to note, Bryce, you're right there. It's important to note that if you forget the rule, try to write out the repeated multiplication so you can remember. So the idea here is if I have x to the m times x to the n, what ends up happening to those exponents? What do you see there? If I have x to some power and then times x to another power, the shortcut is I add those exponents. I'm going to just kind of show you by writing them out what I mean by that, okay? This x cubed means x times x times x. X squared means x times x. So this is the same as x to the 5th power. And you at first, like if you go too fast, you might think, well, I'm multiplying, why do I add the exponents? Because the exponents don't represent the multiplication. They represent how many factors of x you have. And so 3 plus 2 is 5. Yeah. So what do you think you would do with this one then? This would be 2 to the... Well, what's 5 plus negative 3? 2. So 2 to the 2nd. Now I'll show you why in a bit. I can show you the long way. 2 to the 5th really means how many multiplications of 2? 5. So I'd have to write it out. So these rules are here to save you some time. Okay. And then the 2 to the negative 3rd, I don't know if you remember this from algebra or pre-algebra, means you actually put the 2 on the bottom of the fraction. And so that 2 to the negative 3rd means 2 on the bottom. And what do you notice you can cancel out of top and bottom?
3.
And so I'm left with 2 squared. So I'm showing you the long ways around those, but these are the shortcut rules for when you have x to some power times x to another power. And today we're really, honestly, I don't want the number value as much as I want you to get the exponent rule. So I don't want you to type in 2 to the 5th times 2 to the negative 3rd. I just want you to know that it's 2 squared. Okay, that part's the most important part. All right, what about if you raise an exponent to a power? So if you have x raised to some power, and then you raise the entire expression to another power, you actually multiply those together, okay? Now let me show you again what I mean by that, okay? I'll do a little one down here. Let's say I had x to the 3rd, and then I raised it to the 2nd. So what this second power means is, that means x cubed times x cubed. Using what we just used, that would be x to the what? 6th. So the shortcut is, instead of having to write that all out, if you have a power to a power, you can multiply them. 3 times 2 is 6. All right, so don't tell me the numerical value. What would this be as an exponent of 5 then? 5, go ahead, Shane. 5 to the power of 6, and this would be y to the power of 12. What's that?
This is really simple.
Oh. Well, they get more complicated. So, parentheses. What if you have something in a parentheses and it's a product, meaning they're multiplied together and they're raised to a power? You have to raise each thing in the product, and there can be more than 2, to that exponent. So this is a to the nth, b to the nth power. So an example of that is I have 5x squared. I have to raise 5 to the second power and x to the second power. Now, I know you could write 5 to the second power would be what? I could simplify that. But sometimes students, if they see this, they make a mistake and they just write 5x squared. They forget that the 5 has to be raised to the exponent as well. Okay, what about the next one? It would have to be x to the 6 times y to the 6. Now be careful, you can't make that xy to the 12th. The addition rule is only when the bases are the same, so we'd have to leave it like that. Okay, let's go on to what happens when we see things written as a fraction. So kind of like, remember how up above I was canceling things out? What happens is you can cancel out the common factors on top and bottom, and you can raise those to the a to the m minus n. So be careful that you're taking the top power or exponent minus the bottom one. All right. So what I do is, this is, if you want, I can show you the long way. 4 to the 7th means 1, 2, 3, 4, 5, 6, 7. What would I have on the bottom? 4 times 4 times 4. How many factors of 4 on top and bottom can I cancel? 3. So that divided by that is 1. That divided by that is 1. Okay, and I'm left with 4 to the 3rd, but I want you to just keep in mind, is it 7 minus 3 give you a 4? Yeah. So essentially what that 7 minus 3 is doing is it's canceling the common factors. Oh, there's 4 of them. Thanks. Psst. I don't know why I wrote 3. I said 4, didn't I? Did I? I'm sorry. I apologize. 7 minus 3 is 4. Now, we're going to talk about negative exponents in a little bit, but I will tell you, if you see something like this, don't make it x to the 10th. You don't just take the smaller and subtract it from the larger. You have to do the top minus the bottom. This is x to the 3 minus 13 power. Be careful. What is 3 minus 13? It's a negative 10. Now, I'll show you what that means in a second. Well, maybe you can tell me what that means. What does x to the negative 10 mean?
Doesn't it have to be like on top of 1 and on bottom? X in a positive term?
This just means that all the factors of x are on the bottom of the fraction. That's all that means. Because think about it. If I had, I'm going to just show the long way. If I had 3 factors of x on top, and then I know there's a lot. Hold on. Let's see if I can squeeze them all in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many can I cancel out of top and bottom? 3. But do you see how the 10 factors of x are left on the bottom? That means the same thing. Okay, and we'll talk about that down here. Because one of the things I'll say is rewrite this as a fraction. And that would just be 1 over x to the 10th. Okay, more kind of common sense stuff. Thank you. If I have an entire fraction and it's raised to the exponent, you have to do the top and the bottom. So if I have a over b raised to the nth, that's a to the nth over b to the nth. 3, you're next to Michaela. Okay, so now after you do your exponents, I would say let's simplify the numerator and denominator. So what should go on the top of my fraction? 3 to the second, and what should go on the bottom? 5 to the second. And what I mean by that is, don't type this whole thing in your calculator, but we could do 3 to the second. What's 3 times 3? 9. What's 5 times 5? 25. Okay. So I could simplify that one, but I would like you to leave them or practice the exponent rules. Bree, there's a packet right up here for you, dear. All right. 5 squared, remember squared means repeated multiplication, so it's 5 times 5. How about that one? Jane? Over 2 to the third power. And if I wanted to simplify the number part, 2 times 2 times 2 is not 6. 2 times 2 times 2 is 8. Behind Logan. Okay, here's an important one that people screw up. 2 to the 0 power means 1. What? You just got to know it. Anything to the 0 power is a 1. Okay? Even if I gave you 1 million to the 0 power, it's a 1. I'll explain why, but if you don't get it, that's okay. Remember how I said exponents are repeated multiplication? Yeah. So it would have to be the factor that I would multiply by to not change anything. And if you multiply by 0, that would change it to 0. If you multiply by 1, it wouldn't change it to anything. So that is why it's a 1. So be careful. So what's 2 to the 0? 1. On this one, the only thing raised to the 0 is this whole parentheses, but you don't have to even bother with it because it doesn't matter what x is. This whole thing raised to the 0, that part is 1, but what was in front of it? A 2, so this means 2 times 1. Okay, negative exponents. Okay, so remember how we talked about up here, a negative exponent moved, this means I move it to the bottom. Okay, so if you see something raised to a negative exponent, that's the same thing as 1 over a to the n power. So for instance, if I saw 2 to the negative first, that's the same as 1 over 2 to the first. We might have to do a lot of practice with these. Or 1/2. Okay. Well, if a negative exponent moves the top to the bottom, what do you think if I had a negative exponent on the bottom? What do you think it would do? It would move it to the top. You're exactly right. So when I have a fraction, see how I have a over b to the negative n? What I can do is it moves the b up to the top and the a down to the bottom. So this x would now go on the bottom and this 4 would go on the top, and I drop the negative. The negative part just means to take the reciprocal, flip that fraction around. Could I simplify this one now? I could. 4 to the second over x to the second. What's 4 times 4? Careful. 16, yep. Over x squared. Okay, this seems complicated. Sometimes when you have really big expressions, just do one little piece at a time. Remember that negative exponent moves things from bottoms to top and vice versa. So do you see how I have x to the negative 4th? That's going to move that x to the bottom. On the bottom I have y to the 8th. It's not negative, right? So it just stays there.
What if it's 2 negatives? You just leave it.
So I'll do one like that in a second, okay? So that makes this a 1 on top to hold the spot. The x to the 4th moves to the bottom, and the y to the 8th was already there, and it stays there. Braden, do you mean if there was a negative exponent on the bottom as well?
Yeah.
Okay, I'll show you one like that. So you were saying, like, what if this was x to the negative third, and this was y to the negative fifth?
Yeah.
Okay. This x to the negative third would move this x factor down to the bottom, and then it would move this y factor up to the top. So then I would have on top y to the fifth, on bottom x to the third. Yes.
So when you have a negative,
A negative exponent.
in a fraction, obviously,
In a fraction.
so you set them to the top and bottom, you just switch it on the top.
Yeah. Do you guys remember in pre-algebra ever studying reciprocals?
Keeping it flipped.
That had to do with, yeah, multiplying by a reciprocal. But, like, for instance, the reciprocal of 3 is 1/3, 1 over 3. And the reciprocal of, like, 2/3 is 3/2. A reciprocal is the number that you would multiply by to get 1, because 3 times 1/3 is 1. 2/3 times 3/2 is 1. What would be the reciprocal of 1/5? 5 over 1, which we could just write as 5, right? A negative exponent means to take the reciprocal. And so that's really what its definition is. Okay. Now we're going to practice. You ready?